Hello everyone and welcome to the sky this month for July 2023. My name's Paul Martinaitis and this show is brought to you by the Astronomical Society of South Australia. So of course we're in the middle of winter now, some wonderful parts of the sky on display now. Unfortunately very cloudy here in Adelaide at least, but let's hope that changes over the next couple of weeks and months as we go forward. So, like I said, some wonderful parts of the sky are now coming into view, the centre of our galaxy. So you got constellations like Scorpius and Sagittarius, Centaurus, very high up in the sky now with all those beautiful globulars, star clusters, and nebula and so forth. So in this show, we'll look at just a few of the hundreds, literally hundreds, perhaps even thousands of objects that we can look at in that part of the sky. And in the solar system, Mercury and Venus are fairly well placed for observation, as we'll see. And also Saturn is coming up for opposition in August. So that's rising at about 8:30 at the moment. So Saturn's also, we can start to get some good viewing of that planet as well. So as usual, we'll begin the show with a tour of the sky. So we'll begin our tour of the sky in the west. This is the part of the sky that will be setting early in the evening. So this is, if there's any objects that you want to look at in this part of the sky, you want to do that first. And the date is around mid-month, 15th of July, and the time is 9 p.m. So right down the centre here, we can see Hydra. It's in fact the longest constellation. So long, in fact, that part of it is already below the horizon, yet up the top it's sort of still reaching, you know, quite near the zenith. So one of the key objects, of course, in this constellation is one that we've looked at a number of times, M83, still really well placed for taking a look at. So if you happen to get out to a dark sky with your telescope, please give it a go. It's one of the finest galaxies in the sky. And under nice dark conditions, certainly in my 12-inch, I can really see that outer sort of irregular shape, and I get a hint of those wonderful spiral arms there. And you can also often see a bit of a bar coming across, and of course the bright nucleus. So it's really, and it's quite a large galaxy as well. So speaking of galaxies, of course, we've got this region around here, Virgo and Coma Berenices. That's actually now getting quite low. Probably too low for effective observation, but if there's any objects in here that you want to take a look at, probably best to do it as soon as you can. Otherwise you'll have to wait until early next year to get a good view of them again. So moving now over to towards the north, we can see dominating the sky high up is Ophiuchus, together with Serpens, and below it's Hercules. Hercules is one of those constellations, a little bit like Orion, that actually looks kind of like what it represents. You can see there, it actually kind of looks like a stick figure of some sort of person. And probably the most famous object in Hercules is the so-called Great Globular Cluster M13, regarded by many in the Northern Hemisphere as the finest globular cluster, certainly in their skies. So good opportunity to take a look at that globular. And of course, we're in the Southern Hemisphere very lucky because we have 3 globular clusters that are arguably better. You've got Omega Centauri, of course, very well placed at the moment, 47 Tucani, and near the Small Magellanic Cloud, and of course the Parvo Globular as well. So we're actually very lucky. We can actually see 4 of the best globular clusters in the entire sky in one evening. So moving across to the northeast, we have some wonderful constellations in this part of the sky. So we'll talk more about some of them in a later show. Just one I'll point out quickly is Lyra. So that will culminate at about 11 p.m. So if you're around at 11 p.m, that'll be kind of at its highest point. So that bright star there is Vega. And then you've got this parallelogram of fainter stars to the right. And if you look halfway across the top of that parallelogram, that's where you'll find the famous Ring Nebula. Probably it's probably, of all the planetary nebula, the one that has one of the most prominent sort of donut shapes to it. So I'll just see if I can, this is a simulated view through a 12-inch at 115 times. Let's see if we can increase the magnification a bit. There we go. And let's put a Barlow in, so we'll zoom in a little bit. So if you happen to be up a little bit later in the evening, you might want to give that a look at as well. And we'll talk more about this region of the sky in a later show. So moving across now to the east, and we can see we're well and truly in winter now. So here are the great winter constellations. We've got Scorpius, that's pretty much near the zenith now, snaking across the top of the sky. And a little bit lower down, we've got Sagittarius. So when we look in this part of the sky, we're looking really at the center of our galaxy. So before we were looking sort of more towards Virgo and Coma Berenices. That's perpendicular to the plane. So that's why we can see all the galaxies out to large distances, because it's not obscured by dust from the Milky Way. Here, when we look in this region of the sky, we've now turned our attention looking into the center of our own Milky Way galaxy. And you can see there, this is really globular territory. All these little yellow dots, all of the, are some of the brightest of about 100 to 120 or so of the globular clusters that we can readily observe in our own galaxy. So I just want to just quickly zoom in a little bit on Sagittarius. This is really one of the best parts of the sky. I don't really know of too many other parts of the sky where you can see so many good bright nebula and objects confined to such a small area. So some people call this the teapot. I guess this here is the top of the teapot. That kind of is the base. And then here's the spout. So if you identify this triangle here that constitutes the spout, and if you follow that line along to this star here, that's a good jumping off point for observing these various objects. So, and even if you look with the naked eye under a dark sky, you'll actually see these glowing concentrations. You'll see this one here, which is the M24 star cloud, and up above here you can see that with the naked eye as well, and that's the Lagoon Nebula. So we'll take a look at that first. I'll just bring up Telrad just to show you. So we start at that star there, and we'll just move across to there. And so this kind of gives you an impression of what the lagoon will look like. I really like this sort of grayscale photo because this very much represents what you can see under a very dark sky with a nebula filter in, say, something between an 8 and a 12-inch telescope. So on a good night, I can pretty much see all of this detail in my 12-inch, and sometimes you can even see these little dark streaks which kind of cut in to the gas. And it always kind of reminds me of some sort of space monster, because the most prominent feature to my eye is you can see you got these two stars there, and they to me look like eyes, and then you've got that sort of that sinister, some people might say it's a smile, it looks a bit sinister to me, this sort of this monster looking out at you. So that's well worth a look at. And this actually doesn't look too bad even under a suburban sky if you use a nebula filter. And then if we just move just a little bit further along, so there's the lagoon, and if we just move along, so you'll see that in your finder scope to this part here, this is the location of the Trifid Nebula. So that's here. So you won't see the colour, of course, except if you've got a really, really large telescope, you might get a bit of a hint of colour. Now this is much smaller than the lagoon, and it really does require a dark sky in my experience to really get anything out of it. But if you've got a dark sky, you need to use a lot more magnification, and you should actually see this general shape here, and you'll see these 4 dark lanes. 3 of them are fairly bright, and 1 of them is considerably fainter. But you should, with enough magnification and a dark sky, be able to make out those 4 dark lanes cutting through that nebula. So here we are at the Trifid, and now what we're going to do is we're going to move back to the tip of the spout, and then we're going to just move along to this huge glow that you'll see pretty much with the naked eye, but if you're using binoculars or your finder scope, you'll definitely see it. And this is the M24 star cloud. So what we're actually looking at here is all of the foreground stars belong to the arm that we're in our galaxy. What you're looking at here when you look at this star cloud, you're actually looking through a gap in our arm, and you're actually seeing stars that come from an arm, the next arm called the Norma arm. So that's why they kind of look like these faint sparkling stars. We're actually seeing another arm in our galaxy. And I'll just show you here. Here's a better photo. This gives you a good impression of what you can see under the eyepiece on a dark sky. A little bit dimmer, of course, but what you'll see is stars everywhere. And you'll also see these dark sort of lanes zipping through the star cloud. So these are actually dark nebula. So they consist of giant molecular clouds of gas that aren't presently glowing very much, like say the lagoon, which are stimulated by the stars nearby. So these dark nebula consist of these clouds and dust, and they're foreground objects. So they're actually closer to us, and they're obscuring the star cloud behind them. So look out for them as well as you scan through this region of the sky. And then we'll just move a little bit further down to this one here. And this is really probably would be one of my favorite nebula. I believe it has the highest surface brightness of any of the Michelin nebula. And this is the Omega Nebula, sometimes called the Swan Nebula. And I'll just bring up a picture. And there it is there. So you can kind of see why it's called the Swan Nebula. You've got the sort of the body of the swan there, and then you've got the neck, and it kind of hooks over to the left there. And again, this is a fantastic nebula. It has a really high surface brightness, and it responds extremely strongly to an O3 filter. So what you see in this photograph here, pretty much I can see all of that detail in a 12-inch telescope under a dark sky using an oxygen filter. You can see the main body of the swan, and you can also see these extended loops, and you can see all of the wisps and the smokiness around it as well. So we'll now check out the lunar calendar for July. So at the first of the month, darkness began at about 1845 and went through to 5:54 in the morning. And by the end of July, nights are starting to get a little bit shorter now. So darkness will begin at almost 7 o'clock at 18:59, and it will go through to 5:45 in the morning. So the dark sky period will begin at about the 8th of the month, and it will go right through pretty much to the 20th or the 21st, depending on how late you want to stay up. So that's the time where, if you can get to a dark site, and of course if the weather's cooperative, that's the big question, that's where you want to look at your deep sky objects. So the moon phases, full moon was on the 3rd, last quarter will be on the 10th, new moon will be on the 18th, and first quarter will be on the 26th. So looking at the solar system now, this shows you the situation as it was on the 1st of July. And as I'm sure you would have all noticed, Venus, as it was in June, has been really well placed for observation, quite high in the sky and really bright. And that'll continue for the most of July, although as the month progresses, it will tend to get a little bit lower. Mars is also in the early evening sky, and it'll spend most of July near Regulus. So they'll make a nice pair together as they travel together. And then as July progresses, Mercury, which was a morning object, will now swing from behind the sun, and that will now join us as an evening object. And that will actually, as Venus gets relatively lower in the sky, as July progresses, Mercury will rise up higher and get better placed for observation. So July and into August will be really good months for looking at Mercury. And also towards the end of July, you'll be able to see Mars, Mercury, Venus, and also a lovely slender crescent moon together in the evening sky. So looking a little bit further out now, Jupiter's rising, I think, at about 2 or 3 a.m. in the morning. So if you're up nice and early and you want to get a sneak peek into the Jupiter season, it's about, I think, 39 arc seconds at the moment, so still quite big and well worth looking at. And then, of course, as the year rolls on towards its opposition in November, it'll be better and better placed. Saturn, which I think is around here, that's rising, I think, at about 8:30 in the evening. So by late in the evening towards midnight, that will be really high in the sky. So it's a really good time to start looking at Saturn. Currently quite large at about 18 arc minutes, and that will increase slightly to around 19 and a half when it reaches opposition late in August. Neptune also rises at about 10 p.m. in the evening, so after midnight that will be reasonably well placed for observation as well. And finally Uranus, not so well placed. I think that rises at about 3 a.m. in the morning, so that'll never rise very high before the sun comes up. So we'll now look at just a few of the planetary highlights for the month. So as we just saw in the evening sky, that's where most of the action will be occurring. So Mars and Regulus will spend most of the begin the month and spend most of the month fairly close together. So they'll look at like a pair of beady eyes staring at you from the evening sky. And on the 15th, Venus will also be very close, so they'll make a nice triple of objects to look at. And then much lower down in the sky, still caught in the evening twilight, will be Mercury. So it may be a little bit hard to spot at this point because you'll need a really good view of the horizon, and the sky will still be quite bright. But as we get later into the month, so this is now showing it at about 6:15, so this is on the 21st, Mars would have moved a little bit away from Regulus. Venus still in about the same position. They'll be joined by a nice slender crescent moon, and Mercury would also have started to rise out of that twilight light. And then by the 30th, the view will be even better. So this is now showing you at 6:30. The sky is considerably darker, and Mercury has risen quite high. So now Mercury will be quite close to Regulus, and Venus will also be close by. So this, particularly if you haven't seen Mercury before, towards the end of July will be a really excellent time to find it, because it'll make that a pair with Regulus, so it'll be really easy to locate. So you'll be able to see Venus, Mercury and Mars all together in the same region of the sky. And if you have a careful look with binoculars, or even better a telescope, but you can do it with binoculars provided that you steady your arms on some sort of surface or use a tripod, you should be able to see the phase of Venus, which at that point will be a really slender crescent, one of the best times to view the planet, I think. And Mercury will also show a partial phase, sort of a gibbous, sort of fat crescent phase at that point as well. Being the middle of winter, when we're thinking of constellations that are good to look at, we think naturally of ones like Scorpius, for example, which is, as we saw, really high above the sky, Sagittarius, Lupus, Centaurus, and so on. But for the constellation of the month for July, I thought we'd take a look at Musca, the fly. That's a constellation. It's a little bit fainter, and it tends to get lost because it's got so many other great constellations around it, and some of you may be a little bit less familiar with it. So it's a small constellation, but it does have 4 or 5 really nice objects in it. So I thought we'd take a closer look at that today. So the constellation itself is really easy to find. That's kind of its representation as a fly there. Personally, if I saw a fly that big in the sky, I think I'd be running for cover. I wouldn't be worrying about the telescope. But fortunately, it's only a pattern of stars, and quite easy to find because it's very close to the Southern Cross. So if you start at Gamma Crux, go to Acrux, so follow the long beam across, and if you go in the same direction by one length of the cross, you'll be bang on in the middle of Musca. And the other thing that will tell you that you're in the right region of the sky is there'll be a pair of relatively bright stars fairly close together, so that will be Alpha and Beta Muscae. And in fact, one of those is our first object that we're going to look at, and that's Beta Muscae. So that will be the higher of those two stars. So Beta Muscae is a relatively a very close double. In fact, its separation is 1.4 arc seconds, but their magnitudes are fairly well matched. So if you do manage to split them, they'll look like two whitish stars, pretty much the same brightness, and they'll either be touching or very close together. Now theoretically that should be splittable in a 6-inch telescope or above if you use enough magnification, but you will need a very steady sky. So in my 12-inch I have observed it before, split it cleanly, but for example when I tried it last month from home, I was unable to split it at all at any magnification, and that was just simply because the sky was too unsteady. So it's a good test of your telescope, easy to find. Give it a go, and if you can't split it, it just means you need to wait for another night to try it again. Now our next object is also a double star, and that's actually quite near Beta Muscae. So if you're having difficulty with Beta Muscae, what we need to do is just star hop over, so you'll be able to see these in your finder scope, or maybe your Telrad if it's a really faint, a really dark sky. So look for this triangle of stars in this direction from Beta Muscae, and the star we're after is this one here. So this is Herschel 4550. So you won't in fact see it through the Telrad because it's magnitude 7.5 even under a dark sky, but you will easily see it through a magnifying finder such as a 7x50. So this was discovered by John Herschel. That's what that little h means. If it's a big H, that means it was discovered by William Herschel, his father. So you can see here the separation is much more comfortable at 13.5 arc seconds, so that's pretty much splittable in any sort of instrument, and it doesn't require a super steady sky. So through my 12-inch, I was easily able to split this pair at 115 times, and the primary appeared to me to be a bit of a yellowish colour, and the secondary was kind of bluish. So that's a nice one to try as well, particularly if Beta Muscae is giving you grief. So now we have two globulars to look at, and they're quite different globulars, so they make a nice contrast to one another. So the first one is 4833, and that has an integrated magnitude of 8.4, which is not terribly useful. The more useful metric for a globular cluster is what you see in brackets here, which is the magnitude of the brightest star, which in this case is 12.4. So that means the lower the brighter stars are, the more likely it is you're going to be able to resolve that globular cluster. So this is a class a class 8 globular, which means it's relatively concentrated. The lower the class number, the more concentrated it is. So in the above, you can see a photo taken through a fairly large telescope, and this grainy black and white one at the bottom is probably a better representation of what you'll see through the eyepiece, particularly under a suburban sky. Really nice globular, quite a good view under a city sky, but when you get to a dark sky, I was able through my 12-inch to resolve it fairly well. So it's a really nice globular, and it's in a lovely field of stars as well. So we'll just go back to Stellarium so I can show you where that is. So again, here's Alpha and Beta Muscae, and 4833 is just over here. So you can either star hop it, or you can probably find it just by moving from alpha, and you'll see, you should see the glow in your magnifying finder. And our next object is also a globular cluster, and that's 4372. So if we go back to Alpha Muscae, follow along to Gamma, and it's just off of Gamma. So it's just there, still relatively close by. And this globular cluster is very different. So here's 4372. And this really appears more like, to my eye at least, more like well, firstly it's class, you can see the class there, class 12. So that means it has relatively low concentration. So that means it looks more like an open cluster than a globular. And that's certainly how it appears to my eye. And this sketch here kind of shows you a good representation of what it looks like under a dark sky. So there's lots of background stars around, and you'll see sort of a smearing of fainter, 50 or so fainter stars, and that will be the globular. So you note also that it's much smaller. It's about half the size of the previous globular cluster. And interestingly, according to my notes, when I last viewed it under a suburban sky from home, a relatively bright sky, I was unable to see it at all. I was in the right location, I just couldn't see it. But under a dark sky, it's not too hard to see, but it's quite a contrast to the previous globular cluster. And our final object is a planetary nebula, and this is NGC 5189, sometimes called the spiral planetary, because as you can see from that photograph there, it kind of makes this spiral-like pattern. And this is a really nice planetary nebula. And even under in a suburban sky, it can look quite good. So, for example, when I last looked at it from home, under a fairly bright sky, I found at 115 times through my 12-inch, it was still quite apparent. And it looked to me like an elongated glow. And when I added the O3 filter, I could see some mottling along the bar. And with averted vision, I could see a slight hook to the bar. So even under a suburban sky with a fairly large telescope, provided that I used a filter, I could see some of that spiral shape. However, under a dark sky, it was much, much better. So under a dark sky, using the same instrument, it was much more apparent. And to me, it looked like an integral sign from calculus. So it was like a long hook, and it had like a real curve at both ends. And I also saw quite a bit of mottling along the length of the bar. So this is a really good one, really to look at under any sky conditions. So I'll just show you how to find this. So we'll go back to alpha, we'll hop up to beta, and I'll just zoom out a little bit, and 5189 is over here. So I'll just zoom out a bit to give you a bit of context. So it kind of makes a triangle with A crux, beta Muscae, and if you go up here at a right angle, there's the planetary. So you can either use setting circles, or you could star hop using your finder, or you can try and estimate it by placing your Telrad in the right region of the sky. So I hope you enjoy those objects. If you haven't visited Musca before, there's some nice objects to start with, and I hope you enjoy viewing them. Thanks everyone for joining me for this show. It was my great pleasure in presenting it to you. I hope you find it useful and interesting, and let's hope we get some more, start to get some clear cloud-free nights so we can enjoy these wonderful winter skies. So I'll see you again in August. So until then, stay warm and happy observing. Bye for now.